Hi guys, we are back again, and here we are on our task 3 of the NFA assignment. So, yeah, we see that the start state, which is skill 0, the accepting state skill 2, the NFA 2, the starts, and then the accepting. So, the transition table for the NFA is as you can see, where kill 0 being the start state, upon the input of 0 moves to kill 0, upon the input of 1 decides to move to kill 1 or kill 0. State kill 1 on input of 0 can choose to move to kill 1 or kill 2, on the input of 1 moves to kill 1. And then our accept state, which is the kill 2, on input of 0 moves to kill 2, also on the input of 1 moves to kill 2. This is our first NFA. Our second NFA here, where our kill 0 being the start state, on input of 0 moves to kill 0 and kill 1. Kill 1 on the input. Kill 0 on input of 1 moves to kill 1. And then kill 1 on input of 0 to kill 1. On input of 1, we move to kill 1, kill 2. Uh, Kill 2 being our accept state, on input of 0 moves to kill 2. On input of 1 moves to kill 2. We see that the end, the state elimination, that is the NFA to the regular expression. You see that when we eliminate the kill 0 and then the kill 1, before elimination, the edges kill us mapping to kill 0, epsilon, kill 0 to kill 0, that is a 0 plus 1 language, moves through all these, and then we get to eliminate kill 0, a self loop of 0 plus 1. The new edge, that's the kill edge, maps to kill 1, labeled 0 plus 1 or asterisk 1. Hence, the transition table for the automaton after eliminating kill 0 is as seen below. So here, see that the states have bulked up, have been paired with each other, and then in urge we have the languages that he accepts being also in the other bracket or the other side of the table. When eliminating kill 1, the self loop, that is the 0 plus 1 looping on itself. The new urge, the kill is linking to kill 2, kill labeled 0 plus 1 start 1, 0 plus 1, start 0. The automation, that is the automaton after eliminating Q1, only kill S and Q2, kill F refrain. That is, upon all our deductions and everything, we had that we took away kill 1, and then the remaining left was kill S, kill 2, and then kill 2, kill F. On eliminating kill 2, the self loop 0 plus 1, the final edge, that is a kill S, mapping to kill F, results in regular expressions from NFA 1. Okay, so we see that R1 mapping to the regular expression. This is a standard regular expression for contains 10 as a substring, since in the binary string, 1 occurring before a later 0 always deals an adjacent 10 somewhere. Hence, we see that the NFA eliminates kill 0, then the kill 1. Also, from here, we'll go through the process as we went back there in order to result in a regular expression for our NFA 2. The minimum accepted length is 2, therefore it rejects the single string 1, since the first one must be spent entering kill 1 and a further one is still required to reach kill 2. So our question D were three strings accepted by the NFA1 processed with the transition function. We have NFA1, that is our first NFA here, accept exactly the strings that contain 10 as a substring. So we have 1 of where W is equal to the string 10, and then the transition function, kill 0, which is 10, mapping down to our languages here. Here we see that the NFA1 converted into an equivalent DFA. So here we come to use the subset construction to derive our DFA from our NFA. And we have state A being the start state or kill zero. We have our B mapping to the second state, which is kill zero, kill one. Our D mapping to the third state, and our D is also on a set state. Hence, we have the kill zero, kill one, kill two. And our subset construction brought us down to this. And in subset construction, we know that it is 2 raised to the power the number of sets that we had in the number of states we had in our past. But then after the states we get, we are supposed to simplify to the ones that are really and then necessary in our diagrams. We'll end our lesson here today with this diagram where the start states being A maps to itself on an input of 0, maps to B on input of 1, B maps to itself on input of 1, maps to D on input of 0, and D maps to input of 0 itself, and then on input of 1 itself. We would end our class here. Thank you very much for joining us. See you next time.